To save you time, this video is indexed with the following times to skip forward to certain subtopics within this same video. The last section is for using the Ti84. In the last video, we learned that log to base 4 of 64 is asking what exponent do I raise the 4 to get it to a 64, and 4 to the third power is 64. So that's the answer to this. What I want to do is I want to look at this one, which is really obvious and easy to do, and I want to look at it a different way so that we can set ourselves up so we can do advanced logarithms. So log to base 4, this is going to be 4 to the x power. It's some number that I don't know, is going to equal 64, but I want to rewrite the 64 as if it's a base of 4. So that's 4 to the x power equals, and 4 to the third power over here is equal to the 64. And the part that I want you to pay attention to is that we have the same bases with different exponents, and if I set those equal to each other, x equals 3, that would give me the answer to the question. And the reason why this would help is that there are logs that we would have to do that are not obvious like that. Let's take a look at one. Well, here we have log to base 16 is 64, and if I look at 16 to the 0 power is 1, 16 to the first power is 16, and 16 times 16, we're way over the 64. So this isn't going to be able to be done with conventional methods. And what I do notice is that the 16 can have a base of 4 raised to a power, and 64 has a base of 4 raised to a power. So let's take a look at that. So if I put 16 to the x power equals 64, and now what I'm going to do is rewrite both of these as if they're in terms of the base of 4. So I know 4 squared is 16, and I'm still raising this to the x power, and 64 is 4 to the third power. Well, when I look at this, I can simplify, and the law of exponents says when I raise an exponent to an exponent, what I do is I multiply them. So what I have is 4 to the 2x power equals 4 to the third power. Well, when the bases are the same, you can celebrate. And the reason why is once the bases are the same, well, then I can set the exponents equal to each other. So in this case, I have 2x equals 3. And then I divide both sides by 2. And what I get is x equals 3 over 2, or 1.5. Here we see that we're being asked for a log of 128 equals 1 over 32. And obviously, we're not going to get a whole number for an exponent that's going to give us an answer of 1 over 32. But what I want to do is see, are there any roots that the two of these share together? And the answer is yes. So if I have this 128 raised to some power is going to be equal to 1 over 32. Now the 128 and the 32, 32 is a little easier because I know that 2 to the 5th power is 32. And it turns out that 128 is actually 2 to the 7th power. Simplifying on the next line gives us 2 to the 7x power. And on the right side, I have 2 to the minus 5 power. And since my bases are the same, I can then set the exponents equal to each other. And then I simply divide both sides by 7 to get minus 5 over 7, which is the answer. So 128 to the minus 5/7 power gives me 1 over 32. We have log to base 25 equals 1 over 125. So I again want to set these equal to each other. So I have 25 to the x power is going to equal 1 over 125. Next thing I want to do is I want to get 25 and 125 as having the same bases. 125 is the same as 5 to the third power, and 25 is the same as 5 to the second power. And the law of exponents says when I raise a power to a power, I multiply them. So what I get is 5 to the 2x power equals, this is 5 to the minus 3 power, So once the bases are the same, I can set the exponents equal to each other and solve. So when I divide both sides by 2, the answer for this one is x equals minus 3 over 2. For this one, we notice that this obviously is base of 3. So is this a base of 3? And the answer is yes. It's a base of 3 raised to the 5th power. So rewriting both of these in terms of a base of 3 gives us 3 to the 5th power raised to the x equals 1 over 3 to the 1st power. Simplifying on the next line gives us 3 to the 5x power equals 3 to the minus 1 power. The bases are the same, so I set the exponents equal to each other. Then I divide both sides by 5, and I get x equals minus 1/5. So here we have log base 2 of 32 equals x, and this is for the first time giving us an equation. And in order to find x, and I can put an x here, I can put an x here, and different logarithmic equations are going to have the x in different positions. So we'll start this one off with a very easy one. And what we're going to do is we're going to put this in exponential form. And this is saying 2 to the x power equals 32. Well, this one we can do because we know that 32 is 2 to the 5th power. And using what we were using just before, we see that once the bases are the same, we can set them equal. So x equals 5. So this is saying log to base 2 of 32 is 5. And while that one is something that you can do easily in your head, let's move on to some that are not so easy. In this logarithmic equation, we see that we have log of 32 of x equals 4/5. So what this problem is saying is that 32 raised to the 4/5 power equals x. Well, we want to do this in 2 separate steps. First, I want to pull this apart. So this is the same as 32 to the 1/5 power times 4 equals x. Well, 32 to the 1/5 power is asking what the 5th root of 32 is. So what number times itself 5 times gives you 32? Well, inside here, this whole thing would be just a 2. So now the only thing left is what 2 to the 4th power is, and 2 to the 4th power is 16, and that's what x equals. What's different in this example here is that my entire value for log base 3 of x minus 1 equals 10 is being multiplied by 5, so we can just get rid of this 5 by dividing both sides by 5. And when we do that, what we get is, so now we can continue. So what this is saying is that 3 to the 2nd power is equal to x minus 1. I know 3 to the 2nd power is 9, and then I can add 1 to both sides. So here we get that x equals 10, but in future logarithmic equations, we have to check to make sure that our answer is allowed. It has to be non-zero and it must be positive. So if I put the 10 in over here, I get 10 minus 1 is 9. So 3 to the 2nd power, 3 squared, is 9. So that one works out. Now, before continuing, we need to talk about a couple of rules of working with logarithms. So logarithms, being that they're working its inverse of exponents, the rules are actually related to the rules of exponents. So the first one is when we have log to base a of x, that equals n, that's saying that a to the n power equals x. The next one, if we have log to base b of x plus log to base b of y, they get multiplied, then log to base b would then be x times y. And similarly, just as when we divide exponents, so if I had x to the a divided by b, what I do is I subtract the exponents. Well, the same thing happens here. When I have log to base b of x minus log to base b of y, that's going to be equal to the log to base b of dividing them, x divided by y. And those rules will come in handy. Now knowing our rules, let's move on. we have log to base 2 of x plus log to base 2 of x minus 2 equals 3. On this side, I can combine these because the rules for logarithms say that if this is a plus, then that's the same as log to base 2 of x times x minus 2, which equals 3. And now I'll do this expansion on the next line. Now, the log to base 2 of this equals 3 means that 2 to the third power equals this. So 2 to the third power equals x squared minus 2x. And I want to change 2 to the third power to be 8. And then when I subtract 8 from both sides, I'll have a quadratic that's set equal to 0. And then to solve this, I'll factor the quadratic. So I need two numbers that are going to multiply to minus 8, and they're going to add up to minus 2. So one's going to be positive, one's going to be negative. So it's going to be 2 and 4, and the 4 is going to be bigger. So I have x plus 2 and x minus 4. Setting both of these equal to 0, I get x equals minus 2 and x equals 4. Now, when we have two answers, it's possible that one of the two values of x can't be allowed because I need to go back to the original equation and I need to see these can't be negative values in here. So we'll start with the minus 2. Now, in order to check our answers, we have to go back to the very first equation before we multiplied, because when we had the quadratic and we had x squared, it squared the minus 2 to become a positive number. But the question is minus 2 within the domain of x? In order to do that, we'll go back here, and then what we get is log of base 2 of minus 2, and this is outside the domain, so I can't use this one, so this is not an allowable answer. Going on to the next one, so now testing in the original equation, I have log base 2 of 4 plus log base 2 of x minus 2, which is 4 minus 2, equals 3. So log base 2 of 4, well, 2 to the second power equals 4, so this equals 2 plus, and then I have over here log base 2 of 2 equals 1, so and when I add these together, 3 equals 3, so 4 is an allowable value. In this practice example, we see that we're subtracting, so the rule says that we're going to form on the next line log to base 2, and then it forms a fraction. This is the same as saying that 2 to the second power equals this, so 2 to the second power equals x squared over x plus 3. Further simplifying, the 2 squared is 4. And then in order to get rid of the fraction altogether, I can multiply both sides by x plus 3, which gives us 4x plus 12 equals x squared. And to turn this into a quadratic equation set equal to 0, on the next line, I'll subtract 4x plus 12 from both sides, which gives us 0 equals x squared minus 4x minus 12. I'll factor the quadratic. So we're going to have x and x. They have to multiply to minus 12, which means the signs are different. I know the bigger one is going to be the negative one, so it's going to be 6 and 2. And then I'll solve each of those by setting them equal to 0. So I have x equals minus 2 and x equals positive 6. Now I have to test both of those solutions to see if one or both are extraneous. Substituting in x equals minus 2 in the first line. Well, for the first one, I have log base 2 of 2 will give me a 4. So this is going to be 2 minus, and then log to base 2 of 1 to get a 2 here. This is going to have to be a 0 equals 2. And that one checks out. And now I'll check out 6. So this time I have log base 2 of 36 minus log base 2 of 9 equals 2. So now I'm going to cheat and show you how to use the Ti84 at the same time. If I use the log button, that assumes the calculator is going to work as if it's a base of 10, so I need to use the math button. It's going to be the 11th thing. It's easier to click up 3. And when I click enter, it's going to ask for the base, which is a 2. And I'm going to go to the right. It's now asking me of what number, so I'm putting in 36. It already has the parentheses. I push enter and I get 5.16 or 5.17 minus. And then we're going to do the same thing. Math, up 3, enter, base is 2, click to the right, and this time we're looking for 9. And enter, and I get 3.17 equals 2. And when I subtract these, I do in fact get 2, so 6 is allowed.